For nearly 3 decades, the F-22 Raptor stood as the world's most capable air superiority fighter, prized for its speed, altitude performance, and radar-evading design. But as China and Russia invested heavily in advanced radar systems, long-range missiles, and stealth aircraft of their own, the U.S. Air Force recognized that the F-22's advantage would not last indefinitely. This recognition led to the Next Generation Air Dominance (NGAD) program, an effort aimed at developing a fighter substantially more capable than any existing fifth-generation aircraft. The program's roots trace back to a 2014 DARPA initiative known as the Air Dominance Initiative, which funded experimental X-plane demonstrators intended to mature key technologies years before any production decision was made. Boeing's demonstrator first flew in 2019, with Lockheed Martin also building and flying its own demonstrator under separate research contracts. The contract award. On March 21, 2025, the Department of the Air Force announced that Boeing had won the engineering and manufacturing development contract for the NGAD platform, officially designated the F-47. It marked the first time in over 3 decades that a new American air superiority fighter had been awarded a production contract, the previous instance being the F-22. Then, Air Force Chief of Staff General David Alvin stated that the aircraft would deliver significantly longer range, more advanced stealth, and greater sustainability and availability than the F-22 and F-35. The contract was reported to be worth at least $20 billion for the engineering and manufacturing development phase alone, with lifetime production and sustainment costs potentially reaching into the hundreds of billions of dollars depending on the eventual fleet size. Why Boeing was selected over Lockheed Martin? Given Lockheed Martin's history as the manufacturer of both the F-22 and F-35, many observers expected the company to win the NGAD contract as well. Boeing's selection instead reflected several converging factors. Defense officials had grown concerned about the Pentagon's dependence on a single contractor for advanced fighter production, and awarding the contract to Boeing was seen as a deliberate step toward diversifying the industrial base for stealth aircraft. Boeing's design process also relied heavily on digital engineering, including detailed virtual models used to evaluate radar signatures, flight performance, and maintenance requirements before physical construction began. Boeing's years of flight data from its NGAD demonstrator, which had been flying since 2019, further strengthened its position. Northrop Grumman, the only other company that might have competed for the contract, withdrew from contention in 2023, leaving the competition to Boeing and Lockheed Martin. Performance characteristics. According to official Air Force statements and budget documentation, the F-47 is designed to exceed Mach 2 in top speed and to have a combat radius greater than 1,000 nautical miles, a substantial increase over current fifth-generation fighters. This extended range was shaped in large part by the operational demands of the Pacific Theater, where vast distances between bases and potential conflict zones make range a critical design constraint. The aircraft is also intended to incorporate stealth characteristics more advanced than those of the F-22 and F-35 through new materials and airframe shaping. Though most specific details remain classified, the Air Force has released only a single artist's rendering of the aircraft, and no confirmed photographs of the actual airframe have been made public as of mid-2026. Propulsion development. The F-47's engine is being developed under the Next Generation Adaptive Propulsion (NGAP) program, with General Electric and Pratt & Whitney competing to supply the power plant. These engines use a 3-stream adaptive cycle design that can shift between operating modes, prioritizing fuel efficiency for long-range cruising or maximizing thrust for high-performance maneuvers, depending on mission requirements. In February 2026, Pratt & Whitney released updated details and a video demonstration of its XA-103 engine, which included a computer rendering of a fighter airframe that analysts believe may reflect the actual shape of the F-47. NGAP research and development funding was approximately $490 million in fiscal year 2025 and was requested to rise to roughly $514 million in fiscal year 2027, reflecting the program's continued priority within the broader NGAD effort. Collaborative combat aircraft and manned-unmanned teaming. A central element of the F-47 program is its integration with autonomous drone wingmen known as Collaborative Combat Aircraft (CCA). These uncrewed aircraft are designed to carry weapons, sensors, or electronic warfare equipment, operating in formation with crewed fighters under the direction of the pilot. The Air Force has designated 2 CCA variants currently in development, the YFQ-42A and YFQ-44A, with plans to field more than 1,000 of these drones across the fleet, generally paired at a ratio of roughly 2 drones per crewed F-47 or F-35. This approach, known as manned-unmanned teaming, reflects a broader shift in air combat doctrine toward distributed, networked formations rather than reliance on a single highly capable aircraft operating alone. The F-22 fleet is also expected to receive CCA integration before the end of the decade. Program cost and the affordability debate. Cost estimates for the F-47 have varied across reporting, with figures in the range of $300 million per aircraft cited in some early commentary, compared with roughly $80 million to $100 million for current production F-35s. The Air Force has stated its intention to procure 185 or more F-47s. This cost structure has prompted debate within the defense policy community. Critics point to the precedent of the F-22 program, which was originally planned for more than 700 aircraft but was ultimately capped at 187 due to budget constraints, resulting in a smaller fleet than originally envisioned. Proponents argue that given the pace of Chinese fighter development, including the public unveiling of multiple stealth prototypes since December 2024, qualitative superiority must offset any disparity in fleet size. The Air Force's stated approach is a layered fleet structure, with the F-47 handling the most contested missions, a potentially upgraded F-22 fleet covering a second tier, and the larger F-35 fleet handling the remainder of air superiority and strike requirements. International competition. The United States is not alone in pursuing 6th-generation fighter technology. China unveiled 2 new stealth aircraft prototypes, the Chengdu J-36 and Shenyang J-50, within the same week in December 2024, and a third prototype with a distinct configuration was observed in August 2025. Russia is developing an advanced interceptor program known as the Mikoyan PAC-DP, intended to eventually replace the aging MiG-31. Europe's competing effort, the Future Combat Air System, is a joint Franco-German-Spanish program that has faced significant delays stemming from disputes over work-share and intellectual property, with some defense publications suggesting its timeline may extend well beyond 2040. Among these programs, the F-47 is currently the only one to have completed a full engineering and manufacturing development contract and entered low-rate production of an actual airframe, giving the United States what defense analysts describe as a first-mover advantage in pilot training, tactics development, and industrial scaling. Current program status. As of mid-2026, manufacturing of the first F-47 airframe is underway at Boeing's facility in St. Louis, Missouri. Aside with a long history in American military aircraft production, Boeing Defense CEO Steve Parker has credited the program's pace to the maturity gained from years of classified X-plane testing prior to the official contract award. Air Force General Dale White, who oversees the program, told reporters in February 2026 that development was doing exceptionally well. The first flight remains targeted for 2028, with initial operational capability expected in 2029 and broader fleet fielding anticipated through the early 2030s. Research and development funding is projected to peak in fiscal year 2028 at approximately $5.3 billion before gradually declining, a pattern budget analysts interpret as a sign the program expects to transition into flight testing on schedule. The Air Force has also requested $730 million in its fiscal year 2027 budget to build hangars and supporting infrastructure at Nellis Air Force Base in Nevada, which has been designated as the site for the F-47's operational testing. The Air Force has additionally indicated the aircraft is being designed under a built-to-adapt philosophy, intended to allow for capability upgrades over its service life rather than becoming outdated within a decade, and has signaled it may eventually explore a reduced capability export variant for allied nations. The F-47 represents the most significant investment in American air superiority since the F-22 program of the 1990s, combining advances in stealth, propulsion, range, and autonomous teaming into a single platform. Its ultimate success will depend on Boeing's ability to translate digital design work and early demonstrator data into a reliable production aircraft on schedule, a challenge that has proven difficult for past stealth fighter programs. With first flight still 2 years away and full fielding not expected until the next decade, much about the program's real-world performance remains to be demonstrated.